Lester, Wushu Engineer. A short while ago, I uploaded a video showing the development and testing of the Slip-Skall Armor Mark 1 design. I didn't call it that back then, but it's been through a few developmental stages. I strongly recommend watching this earlier video for full context on and a description of the Mark 1 pattern Slip-Skall Armor. To sum the video up, I designed a type of a stab-resistant, soft, fabric-based reactive body armor based on a very old video that Skallagrim uploaded on his channel, during which he was doing a few stab and cutting tests against a particular type of fabric which behaved in a way that indicated to me that it could actually be developed further. The idea has developed a lot further since then, but the original Mark 1 Slip-Skall Armor was designed to move in a predictable and constrained way to help in defeating knife penetration vectors. I tested the design by hand, in other words by using hand strikes and stabbing motions with a knife, and the Mark 1 pattern showed considerable promise. I got a few comments on that video indicating interest in me developing the design further, so I went about doing just that. Now, before I go any further into this video, and hopefully before I've lost too many viewers due to my dry presentation style, I want to discuss the future prospects of this design. The obvious but flawed conclusion that many uninitiated folk may come to is to patent the idea and make big bucks off it. This is a mistake often made by anyone who has not gone through the patenting process. I have, and I own a couple of patents in ballistic protection, so I know whereof I speak when I say never again. George Sprague of the Slingshot channel fame has a brilliant video on his channel discussing the hidden drama and costs associated with the patent process, and I agree with his conclusions. Patents are an incredibly expensive waste of time, really, for small inventors or companies. So after discussing the idea of the Slip-Skall Armor and where we want to go with it with the Wushu scientist, we are now currently considering making the Slip-Skall Armor concept fully open source to anyone in the community who wants to build, develop, sell, or otherwise commercialize it, with the proviso that we get credited as the original designers of the system. Let me know in the comments section what you guys think about that. If there's enough interest, we'll go through the full development cycle, send samples for full NIJ stab testing at an independent testing laboratory in Melbourne, and make all the CAD plans, materials, selections, and details fully available on our Wushu Workshop website for free. There's even scope for the design to be built using more conventional materials, such as nylon webbing instead of the ultra-high molecular weight polyethylene felt that I've used in this current design. Potentially even more primitive materials could be used for those who want to test the concept using period-accurate materials and manufacturing techniques from various historic periods. So on with the video. One of the comments on my previous video was regarding the little strips or straps that form part of the design. The commenter suggested that these straps could be riveted onto the backing fabric layer to improve their range of motion and freedom of motion. This was a good suggestion, but I ended up not incorporating the idea into Mark II for three main reasons. And I'll pick up the now somewhat battered original Mark I Slip-Skall Armor just to illustrate this. So the most important reason that I opted not to go for riveting each of these straps onto the backing plate is that although these straps or strips should be free moving, they must also be constrained enough such that they actually spring back to their original position. So if I show you moving this strip to the side, and then it's springing back to roughly its original position. This is necessary to avoid the strips being displaced and getting caught on fabric or what have you, perhaps just through friction with the base fabric layer rotating out of position and then remaining so. Of course, that would introduce weak points into the armor. So I opted to go for the straps being part of one continuous strip of material. As you can see, this material is continuous along the top and just sewn onto the backing, the backing layer. This automatically causes the straps to want to return to their original position because it's being constrained here. It does impinge on their movement, of course. There is some cost, so it's a little bit of give and take, really. But this is what I decided to retain. The second reason that I didn't incorporate rivets is that I wanted to make the Slip-Skall armor to be completely non-metallic, if at all possible. Metals are typically quite dense compared to other materials, and incorporating metallic rivets, which are the most commonly available types of rivets, would increase the weight and bulk of the armor because, firstly, as I mentioned, metallic rivets are a little bit more dense than other materials, and they're also bulkier. They're bits that project on either side, so it would tend to make the armor a little bit more bulky as well. And finally, the third reason that I didn't use rivets is that using rivets would increase the complexity of manufacture here considerably, and time, because then each and every one of these little straps would have to be individually riveted onto the backing layer, rather than just a strip of straps, being sewn on to the backing layer. So that's why I retained this kind of design. As I mentioned, there were quite a few requests to develop the armor concept further. There's an obvious way of increasing the protective capacity of the Slip-Skall Mark 1 armor design, and that is by incorporating some kind of rigid elements into the design. It's simply a lot harder, it's simply a lot harder to stab through solid rigid materials than through fabrics, because of course stabbing through a fabric you're having to essentially cut a whole bunch of strands of a material, whereas a solid object is literally a solid wall, if you like, of material that the knife blade first of all has to pierce through, and then the rest of the knife has to be able to slide through easily. Very difficult compared to fabrics. However, incorporating rigid elements always comes at a cost in terms of both weight and flexibility in an armor. In this case, though, the inherent properties of the Slip-Skall armor design can easily accommodate for rigid elements in these little strips or straps that move under these, move on top of these slippery under fabric layers. I'll typically refer from now on to these strips or straps as lappets, because I think it's probably the most accurate description that I could find for what these are. Because these lappets are free moving, the rigid elements will have far less of a tendency to reduce flexibility in the design. In addition, because the lappet layers overlap each other, as you can see, lappets overlapping, because they overlap each other in a staggered array, any impact on the rigid elements of the top layers of lappets will tend to collide with the other rigid elements on the underlying layers of lappets, will tend to collide with gaps between the rigid elements on the underlying layers of lappets, and will tend to then spread the impact over a much larger area of the armor. And this benefit, of course, could potentially lead to enhanced impact protection. So as I mentioned earlier, I didn't want to use any metallic elements in this armor. So I was first considering bonding rigid pieces of a composite, like a G10 fiberglass, for instance, onto the lappets. However, that would introduce an insane amount of work for me. and also, if it's meant to be manufactured in future, it would introduce an insane amount of additional work, because each and every lappet would have several pieces of composite glued onto it. So imagine cutting out thousands of pieces of G10 fiberglass and gluing each and every little piece onto one of these moving lappets, onto a floppy bit of fabric in a precise arrangement. Yeah. I thought about it and I thought, I don't think so. So instead of doing that, I decided that I would somehow form a paste-like composite into the required shapes while it's still unset or uncured, and then essentially put those blobs or like geometric shapes of the paste composite onto those lappets in some way. I went through a few design iterations on paper and in CAD before I decided on a final rigid element layout. The final pattern of rigid elements should be segmented to allow for some flexibility of the individual lappets, but the gaps between rigid elements should not consist of straight lines, long straight lines, because of course that would allow a knife blade to easily slice between rigid elements. And historically, a good example of how this was achieved was in some forms of traditional Japanese armor, where close-fitting patterns of hexagons. Sorry, I don't have a great hexagon graphic for you at the moment, but if you can imagine a bunch of hexagons right up against each other, all overlapping and staggered as well, because of the natural shape of the hexagon allows it to be staggered in an array, which still allows a lot of flexibility, but there are no long straight gaps between rigid elements allowing a blade to pierce. So clever design. I simplified the staggered pattern of disc. I simplified the idea of hexagons down to a staggered pattern of discs, just for simplicity's sake, because discs are easier to cut or be stamped out using conventional disc punches, or I decided that I would go with the discs. But then I realized that the lappets themselves were flexible enough in their arrangement to actually use bigger rigid elements on each of the lappets. This would provide better coverage and improved impact protection due to the larger surface area of the rigid elements that stretched essentially the width of the lappet, and then because of the staggered arrangement would overlap the center of the rigid elements on the lappet layer below it. But in this case, I couldn't just use a simple arrangement of squares or rectangles, because of course that would introduce a lot of straight line gaps between those rigid elements, which would allow a knife blade to pierce through. So I decided to go with a set of discs with semicircular cutouts, allowing them to be placed alongside each other to form a fairly continuous segmented arrangement with circular curved gaps that would tend to prevent a linear knife point from slipping through that gap. Well, I have a few things to show you here in terms of how I've progressed this design and in terms of the manufacturing techniques that I'm using. And rather than take a whole bunch of photographs and walls of text to explain it, I thought I'd just do a brief show and tell. So the idea was to put somehow or other essentially emboss or glue rigid plates onto the straps of the the Slip-Skall armor. So I thought that instead of doing that, I would actually create a composite, just like a thick pasty composite made out of finely chopped Kevlar fiber, so Kevlar microfibers in a typical 2-part epoxy. Just to get that on applied to the fabric, though, that'd be quite a tricky task. So eventually I decided that what I would do would be to make a silicon mold, literally apply the paste into the mold indents, and then place the fabric on top of that and let it set, let it cure, so that it would in one fell swoop create the little plates out of the composite paste and also bond them onto the surface of the fabric. It sounded like a great idea to begin with. After going through the process, there are a couple of things that I think can be improved. So first of all, this is what I used to make the mold. As you can see, it's essentially just a little boxed in section. Well, it's actually not so little. This represents quite a large volume. And that was one of the first of my mistakes, because all I had on my shelf in the workshop was 1 kilogram of silicon. That was not nearly enough. Silicon mold agent. That was not nearly enough. And the other problem with that particular 1 kilogram batch of silicon mold agent, or mold, whatever you'd like to call it, is that it was sitting on that shelf for quite some time. So I actually got it way before a certain pandemic made its first appearance. So it's a couple of years old, at least 2 to 3 years old, and so it was way past its use by date. It was unusually thick and chuggy, and didn't really set in the way that I expected it to. It wasn't runny enough when I was pouring it into the mold. The mold itself is just made of a backing of core flute plastic with some PVC angle pieces that I used as walls. They were just something I had lying around the workshop that I could use. These little discs that I cut out, this took by far the longest out of just about anything in this process. Stamping all of these out with a large punch, and then shaping some of them. So there are 104 of these little discs that had to be cut out and shaped and then glued together. They're made out of a polypropylene plastic, 2mm thick polypropylene plastic sheet, just stamped out into this mold. So this allows me to make 52 centimeter long strips of these little straps or scales or tags. I then, as I've already hinted at, I poured the silicon into the mold, and I got something that was usable but really, really, really crummy. So the quality of this mold was very, very crummy because, as I said, a number of factors combined together to make it not particularly good. First of all, I didn't have enough, so it's pretty thin in places, and not actually evenly spread through the mold. I don't have access to a vacuum chamber, so I can't evacuate it and get rid of the gas or little air bubbles and pockets. So there are a bunch of little air pockets and bubbles throughout here, but that's not the big issue. The big issue is just that it was of a low quality because it had been on the shelf for a long time. But anyway, that was the mold that I made, and I cast one set of these discs. And as you can see, this is where the process went awry a little bit more than anywhere else during the process. You'll notice that, if I can get the camera to focus on this, that while some of these are okay, many of these discs are very ill-formed, and there are areas that didn't come through because of the process I was using. So I was putting this cloth on top. As you can actually see, the adhesive leaked through into the fabric, as I wanted it to actually, bonding it very firmly onto the fabric, at least in places, and where it was making proper contact with the with these little discs in the mold. The big problem, though, you can actually tell from these few here, the worst of them, is that when this made contact, I tried to keep, I put some weight on it, but it still sort of, I think, created a bit of suction force. It pulled away, which kind of messed around with the composite paste in the mold and pulled it away. So you'll see these like little sections that are like almost like vacuum bubbles in the silicon mold, or at least in the paste that was setting in the silicon mold. So that's not good. In future, what I think should be done is that the paste should be put into the mold, wiped clean off the top, and then allowed to set for a period of time. And while it is not quite fully set, still, but hard enough to not deform or get squished around and moved around in the mold, then a second layer of fresh epoxy should just be wiped over the surface of the discs in the mold, and then the fabric should be applied and pressure should be applied. And I think that will make a far better product, and you'll get discs that are like these few disc bits that I put into molds separately without any backing on them. You'll see that it's quite well formed, quite solid and substantial. So because the material I used to make the mold was 2 millimeters thick, these are a little bit less than 2 millimeters thick because they weren't. I didn't have it evenly applied, but it's still quite tough. It's not something I can't break. I can squish it around and break it, and of course the epoxy is not properly cured yet, but pretty tough. It's very light composite as well. So although this is not ideal, certainly subpar to what I actually wanted, it'll be good enough, I think, to get a rough idea of what its performance is going to be, whether it's going to be an improvement over the Mark 1 Slip-Skall Armor. I'm hoping that it will be, so we'll see after it's been properly assembled and ready for testing. So this is the final product just prior to testing. I just thought I would show you what it looked like fully assembled. You'll notice that I decided not to cut the lappets into points at the end. I thought in this case it's pretty much a bit of a waste of time, really. I'm not convinced that adds much in terms of functionality, so I've left them just purely rectangular. You'll notice, as I mentioned, when I took this out of the mold, first of all, as I mentioned, the plastic discs are badly formed. I don't know if you can see that with the light glaring on it. They're badly formed, and I have figured out, well, I have some ideas how to prevent that from happening next time, but for the moment these will just have to do, and we'll see what kind of performance this provides, this is capable of. As you can see, it's still very, very flexible. It's not interfering with the movement of the armor at all. It is a little bit heavier, marginally, because of course we're introducing this dense epoxy based composite. They're quite hard, actually, now that they've set properly. I'm always impressed by this kind of composite structure, just composed of essentially a paste of epoxy and Kevlar microfibers. We'll put this up and see how it performs. After building the armor sample, I then proceeded to perform full pendulum tests on both the Slip-Skall Mark 1 Armor pattern and the Slip-Skall Mark II. Before doing these tests, however, I thought it might be beneficial to perform some tests against different types of materials that people are perhaps a little bit more familiar with and may consider to be stab proof. I decided to do these tests really just for context. So there's no real reason in this video for these tests to be here other than to provide a little bit of context for a comparison point to show you how extreme the pendulum stab test can be for an armor sample. I tested 3 samples for these comparative tests, for these contextual tests, if you like. One was a 0.5 millimeter thick galvanized mild steel sheet. One was a 1.9 millimeter thick, so nearly 2 millimeter thick aluminium sheet. And one was a stack of 3 2 millimeter thick polycarbonate sheets, which of course would represent a 6 millimeter thick piece of polycarbonate. And this is what those tests looked like. So just to go over the targets that I used in this informal set of tests against some materials that people might consider to offer you some stab protection. This is a piece of galvanized steel flashing. It's mild steel and it's 0.5 millimeter thick, so not terribly thin, not terribly thick, but as you can see, just to put into perspective how difficult it is for samples to survive these tests, the knife went straight through this. So the second target that I that I used in the test needs a little bit of explanation. This is a 1.9 millimeter thick piece of aluminium. So it's quite, it's not thin, but you know, it's nearly 2 millimeters thick. I didn't have a larger piece, and this is part of some previous project that I was doing, hence the bend in the piece. So it wasn't ideal for the test. In addition, the knife point struck right on the very edge of the sample as well, which meant that if you look at it from the side, there was a lot of deformation here, which absorbed a lot of the energy of that swing, which wouldn't otherwise have been there if this was a big flat plate of aluminium. Same thickness. It would have penetrated far more if it had been a larger sheet of aluminium of the same thickness, and if it had struck in the center instead of on the edge. So this is a little bit misleading in terms of its performance, and yet despite all of that, there was still a noticeable penetration through this nearly 2 millimeters thick aluminium sheet. So the final test piece that I used was made up of 3 layers of 2 millimeter thick polycarbonate. Now usually people consider polycarbonate to be fairly protective, and it is. But as you can see, the knife penetrated through all 3 of these layers. I did 2 tests against this. One in which the pendulum swung from 55 degrees and the other from 65 degrees. Obviously the 65 degree penetration is the bigger of the 2, while the 55 degree penetration is smaller. The interesting thing about this though was that despite the fact that the blade penetrated the sample in both tests, it was essentially kicked out of the sample by the polycarbonate springing back, almost as though it absorbs a lot of mechanical energy in terms of elastic energy, which it then uses to essentially knock the knife blade straight back out of the penetration point. So that was an interesting reaction, but still penetration through what amounts to 6 millimeters in thickness of polycarbonate plastic. Excuse the condition of these samples, they're just some offcuts that I had lying around in the shed. So for a fabric to survive a test that, as you can see, all of these solid monolithic targets actually fail at to a greater or lesser extent, that's actually very difficult. Very difficult for a fabric of any kind to survive this kind of torture. These tests are not kind on samples, and passing this test using fabric armor is very difficult. Bear these contextual tests in mind, and we can go into the Slip-Skall Armor testing. I first tested the Slip-Skall Mark 1 pattern, and this is what those tests look like. I'm going to start off at 45 and we'll see what it does. Not ideal. So that going directly on with total penetration through all layers. What I might try now is I might try at an angle, just see if I can get this at an angle and see if that makes any difference at all. So there was a bit of a difference there, no full penetration. I'll try that once more. Get it at a bit of an angle. full penetration. So those were 3 full penetration. Right, let's go through the post-mortem. So my original design for the Mark 1 Slip-Skall Armor did not survive that test. And as you can see, significant penetration wounds through the back. These would have proved fatal, most likely. In the armor's defense, as I mentioned in my previous video, the test that I've chosen to do against knife and against stab and cut resistant armor is actually a little bit unfair. It's quite hard. It's harsh on the armor samples. As I mentioned, that pendulum arm is essentially like it's like a war pick with a 5 kilogram head and a rigidly mounted sharpened blade on the end of it. It is a very, very difficult test to survive. So, as unfair as it is, that is the test that I've chosen to use on my channel. It's the easiest way for me to make things consistent, to keep variables like energy and impact force and that consistent from one test to another without introducing human variation. So it is what it is. It's not particularly fair, but it is it's fairly objective and consistent. So this did not pass at all. Against a human opponent, it is likely that this may actually provide sufficient protection to help you survive, but not against the test that I've chosen on my channel. As you can see from the test and the post-mortem, the armor failed substantially. However, I was not satisfied with that test alone because the results differed so markedly from those of my first manual tests. I thought that the harder foam block backing that I was using in my standard pendulum test was the main issue causing the large discrepancy between the hand and pendulum tests. So I decided to test the Mark 1 pattern again, using the pendulum, but with the same burlap sack stuffed with old clothes as a backing that I used in the manual tests. And this is what that test looked like. So it looks like of all of those strikes, there was only one that penetrated. You'll see that I've marked off the locations of previous penetrations, so this is a new one. But aside from that, I don't see any other penetrations. As I thought, the backing played a significant role in the armor's performance, and with the burlap sack stuffed with clothes as a backing, the Mark 1 armor actually performed very well indeed. Which of the two backing options are closer as analogs to the human body? It's up to debate. Some parts of the human body are soft and others are hard. Combine that with movement of the body relative to the knife thrust vector, and the Mark 1 pattern could still be a potential solution under certain conditions. It is obviously a lot lighter than the Mark 2 pattern, and it's less bulky as well because it doesn't contain the additional width of those hard elements. But that's not what we're here for. We're actually here to test a new and improved Slip-Skall Mark 2 pattern. Being buzzed by a wasp here. Okay, so that kind of skimmed along the edge. I'll try and get it center of mass. 85 degrees, roughly. Yep, so that does not appear to have penetrated. Penetrated through the edge of one of the front-facing lappets and was stopped by the one behind it. So it didn't actually impact the plastic discs on the surface of the front lappets. Penetrated through the felt material and then was stopped by the second layer. So no penetration past the second layer. We'll try that again. So that's quite promising. I'm going to try and up the ante a little bit now. I'm going to try and get it up past 45, maybe 55. Yep, that does not look like a penetration. When it bounces back like that, it's unlikely to have been a penetration. Again, it actually skimmed past the front lappet and impacted on the second layer of lappets behind it. Didn't actually penetrate fully to that layer, and we didn't actually get a penetration, doesn't look like. So that's looking really, really good. We'll try one more time. This time I'm going to try and get it in a different location because I'm hitting in almost exactly the same spot at the moment. And we'll go up to about 60. That does not look like it penetrated. And we have a look at the Slip-Skall Armor Mark II. And as I've already discussed, there were significant weaknesses introduced as a result of a suboptimal manufacturing process that I used to put the discs on the front of the lappets. As you can still see, I mean, you can see quite clearly that they're malformed. Some of them are ridiculously thin or have large air pockets in them, so very, very suboptimal. And yet, despite that, this actually performed quite well. The worst, I wouldn't call it a penetration, it is a marginal penetration of the backing sheet, which you might be able to see if I hold the armor like that. As you can see, this would not have proved fatal. It would have just been literally a couple of millimeters of the tip penetrating there, and maybe not even that. But the worst of these penetrations, which was the one I've just shown you, actually happened in the least optimal, a very suboptimal location, which was between lappets. So it actually skidded past the front lappet, penetrated through that, and then impacted the second layer of lappets. And as you can see over there, encountered a poorly formed, a malformed disc section. Despite the fact that this was not properly formed, that it was not a continuous disc section, it still halted its progress sufficiently so that when it got to the backing layer here, the penetration was limited significantly. So I'm actually quite impressed with how well this arrangement performed. Yeah, there's not a whole lot more I can say about it. And that, I might add, was at a 65-degree angle. And I'll put, in the video, I'll put what that actually means in terms of impact force and impact energy. But it's more than just that, because as I've mentioned before, even for a human being, even generating that same amount of energy and impact force, the knife behaves differently because of the joints in the wrist, perhaps also the elbow and the shoulder. But as you're stabbing forward with the knife, these joints flex slightly, which means that the angle of that the attack vector changes slightly. Some of that energy is actually absorbed into your body structure as you're stabbing. So it's not a perfect similitude of a human being stabbing forward with that level of energy. But nonetheless, as I've said, limitations of the tests aside, this has performed remarkably well. And there's a bit of one of the discs that fell off there. I think with improved manufacturing techniques, as I mentioned when I was discussing this at first, once it just came out of the mold, with those improved manufacturing techniques, this could actually be a really, really good solution. Very flexible, very mobile, very reasonably low profile. It's obviously got more profile to it than my previous iteration, than the Mark 1. But astounding levels of stab protection. And with the added benefit that because of the way that the discs are arranged, it will provide a certain level of impact resistance as well, impact protection. So it will act, the discs as they impact with lower levels of lappets and other discs, will act to spread that impact over a larger area. So I think this is well worth investigating further. As can be seen from the Slip-Skall Mark II pattern test and post-mortem, this pattern of armor worked exceptionally well. There was only one significant penetration, which still would not have been deadly to the wearer, and this penetration occurred in association with an area of the armor that was protected by rigid discs that were physically compromised by my original subpar manufacturing process. As such, I'm relatively confident that a well-manufactured version of this armor would have survived these tests with no penetration whatsoever. It's certainly an encouraging set of results and a marked improvement over the Mark I pattern. If there is growing interest in this subject, I will follow this up with a few more videos exploring this, including potential armor vest designs. As I mentioned in the beginning of the video, if I see enough interest, we'll make the entire design open source, shoulder the cost of official NIJ testing, and upload all relevant info to our website. Let me know in the comments below whether you would like me to do that. I hope you enjoyed this video, and I'll see you all again next time. Cheers.